Now we can take a look at limits as x goes to plus or minus infinity. Let's start off with a quick example. Let's say we have a function called f of x. And we'll give a little bit of information about what the graph of our function looks like. So the graph looks a little bit like the graph of the parabola, y equals x squared. But at the point where x is equal to 1, the graph stops climbing and becomes just a horizontal line. So we've got this kind of strangely shaped function here. Now let's say we want to calculate the limit as x goes to infinity of our function of f of x. And as x gets really big, we want to figure out what number are the y values approaching. So as x gets really big, the y values are just 1 all the way across here. So the y values are approaching the number 1. The limit as x goes to infinity of our function is equal to 1. If we wanted to calculate the limit as x goes to negative infinity, of our function, then we need to look at what is happening as the x values are getting increasingly negative here. We need to figure out what is happening to the y values as x goes to negative infinity. So as we trace across this part of the graph, the x values are getting increasingly negative and the y values are just increasing. They are not approaching any one specific number, they're getting bigger and bigger. So we could say they are approaching positive infinity. Limit as x goes to negative infinity of our function is positive infinity. It would also be correct to say that the limit does not exist. I'm going to put that in brackets because saying that the limit does not exist is a less specific answer. It's true that positive infinity is not actually a number, so the limit technically does not exist. But by writing plus infinity here, we are saying that the limit does not exist, and we're giving a little bit more information as well as to what the shape of the graph looks like. So now before we try another example, we need one useful fact. Okay, it helps us whenever we're looking at limits as x goes to either plus infinity or negative infinity. So I'll just write limit as x goes to plus or minus infinity of 1 over x to the n is equal to 0. And that is true whenever n is positive. So what this is saying is that as x gets really big, whether it's a positive number or a negative number doesn't matter, but as x gets really big, 1 over x to some power is going to get very close to 0, provided that's a positive power. Okay, so let's try a bigger example now. Let's find the limit as x goes to infinity of 5 minus 2x cubed over 1 plus 3x squared. So this function that we're looking at here, this is an example of what's called a rational function. Rational function is just a polynomial divided by another polynomial. And whenever we're looking at a limit as x goes to infinity, or a limit as x goes to negative infinity of a rational function, there's a specific technique that we use to find the limit. What we're going to do is divide each term by the highest power of x that appears in the denominator of the rational function. So highest power of x in the denominator is x squared. We're going to divide each term by x squared. Okay, and we're going to keep our limit expression on here. So we've got the limit as x goes to infinity of 5 over x squared minus 2x cubed over x squared all over 1 over x squared plus 3x squared over x squared. So we have not actually changed the function. By dividing each term in the numerator and each term in the denominator by x squared, we've just changed what the function looks like, but we have not actually changed the function itself. So now we can do a little bit of simplifying. So we'll recopy our limit sign. We got the limit as x goes to infinity of 5 over x squared minus 2x all over 1 over x squared plus 3. So just doing a little bit of simplifying here in cleaning up those powers. So now we can go back to our useful fact. Remember over here, whenever we're dealing with a limit as x goes to infinity, or as x goes to negative infinity, whenever you see 1 over a positive power of x, that term there is going to 0. So even if we have something like 5 over x squared, you can think of this as 5 times 1 over x squared. As x goes to infinity, as we put bigger and bigger numbers into the denominator here, this expression is going to 0. Something like 1 over x squared, that is also going to 0. So all thanks to the fact that x is getting really, really big. Okay, so this is looking like the limit as x goes to infinity of negative 2x over 3. And now, as we imagine x getting larger and larger, this expression here is going to negative infinity. Again, it would be still correct to write does not exist because negative infinity is not a real number, but it gives us much more specific information to say negative infinity. And later on in the course, we'll come back to this idea of limits as x goes to plus or minus infinity when we get into curve sketching.